So I'm going to start with the most important slide for me, and this is the slide of the people that really did the work. Okay, I'm only presenting, but it's really a group effort talking about social neuroscience, and I want to mention a few words, a few names. Lauren was a PhD student, the first PhD student. Greg was a postdoc from physics, now the faculty. Janice and Chris were postdoc, now they are faculty in Johns Hopkins. Asia is a postdoc, Yara now is the faculty in Tel Aviv. Yulia Liana is the faculty in Israel, and Elise is the postdoc. This is the people that did most of the work. If there is like one message that I want you to take from my talk is that we should stop studying people. So if there is like one point that I want you to take out of the talk is that we should not study brain in isolation. I know that it's more easy, and scientists we like to control the parameters we are studying. So working in this setup, that one brain interacting with the computer is more easy for us, but I think we know something about cognition. And I want to convince you of that. Because we always know that the people we meet influence who we are. So in a way, there are many forces that create us as human beings. And if we want to understand one brain, we need to understand how it's connected to other brains. And actually, the tendency to look only at the individual is running way back. And I want to start with René Descartes, which was mentioned before, because I think he laid the ground to this notion, saying, I think, therefore I am. So for Descartes, the focal point is you, what you are thinking. And now the task is to go from what I'm thinking to the outside and to realize that you are not a dream in my mind, and I'm really giving talk time in IDC. Right? So now there is a gap for Descartes, because he starts with what he has in his own mind, and then he needs to connect his brain, his body, to other brains. By the way, how many people now worry that they are dreaming and it's not in IDC? Not too many. So I want to go to another statement that comes actually from Ubuntu philosophy, from Africa. And as you will see, this is the opposite statement. It says, I am because we are. Right? So for Ubuntu, a person is a person to other person. So you are connected to other people and you are defined by other people. So now the Descartes paradox is already vanished, because if I will have never interact with a human being, I will never have something to say. Right? So I will give you two examples of how social cognition is embedded everywhere. Think about a tree and think of what you can do with trees. And I'm going to stop after 10 examples. Give me 10 examples of things you can do with trees. Okay. What? Fire, actually. The owls, wild owls, more. Say, yeah. More. Swing, more. Food, yeah. Paper, yeah, more. Kill, yeah? Someone say kill? Yeah, you can, I guess you can also kill. More, two more. Climb, air, yeah, photosynthesis. Okay, that's good. Actually, this is not, we can do, trees can do it for us. So basically, you say anything, like getting food, floating device, I want to say floating device, cooking, making fire, build furniture, papers. It's also interesting to note that the more complicated your social structures, the more you can do with trees. And as Yulia was saying, even in ag tree, right? So now think about it, when you look on a tree and you think what you can do with it, how many of these users were learned from other people, and how many of these users you invented yourself? And immediately you will see that everything that we know about is coming from our social structures and the embedded knowledge across generations. Now let's go to the other example of language. Another, I will take an example from Wittgenstein. And he asked, what is the definition of the word game? Is game related to your playing together? And then you can see, I can compete against myself. Is it related to your physics? No, I can play with my mind. Is it to win? I'm not sure what is the definition of winning when you play against yourself. Is it played by rules? No, because sometimes we have open-ended games, right? Is it to survive? Another way to say what you are talking about, survival and games have nothing in common. And now I will remind you other type of games in different cultures, and you can see that there is a lot of connection between survival and game. Do you want to decrease the light a bit? I think you will see the slides way better. Oh, there is someone that knows how to do it? Someone know? Okay. Liran will try. Okay, and I will continue in the meanwhile. So basically, survival, as you will see, is related to a different era. So what you learn from Wittgenstein is two important notions. First, that there is no one definition for a word. It's really related to the way you use it, and in different contexts and different cultures use it in a different way. But the most important point is that the meaning of a word is grounded in the interrelated norms shared by a community of speakers. Okay? So we didn't decide about the notion of a game. We learned it from other people. So again, if you want to understand language, you need to understand how people use it in the world. Again, outside of your brain. Yeah, that's better. So going back to the notion of I am because we are, and now we have to think about the forces that make who we are. And this statement, I think, has two meanings. One of it is very humanistic, right? You can say the humanistic aspect, because now you have to ask, who is this we in the game? And the we are can be all of us, because, I grew up in Jerusalem. Now I'm living in the US and speaking in Herzliya, right? So there's many cultures around, and I can communicate with everyone. So that's like an amazing thing about communication. But there's also like a dark side to this statement, because the we can be us, but not them, right? And now we're living in a world that, your identity is what defines you. I was just traveling in Morocco with my family, because my mom is from Morocco, and I read like a piece in an Haaretz that the guy was saying that he's a liberal, but he prefers Miri Regev because she is also from the East. And I was saying, I don't know, everyone try now to go into their sectors. So basically, this has become a very important point, and you see it also in America now. So we have a tendency to do in-group and out-group effects and define our we as a closed group and then segregate it from other people. And you can see it all around, right? Although you can talk with everyone, we tend to split it into groups, and it doesn't matter which group is it, there are many, many ways to separate humankind, right? So in the first part of the talk, I'm going to talk about more the optimistic, how we can simply talk with other people and how we are influenced by other people. And in the second part of the talk, I will tell you about our experiment now to start to understand also this phenomena of being uncoupled from other people. Okay? And I'm a neuroscientist, so the talk is going to be about the underlying mechanism by which we communicate, being able to be influenced by other people and being able to be uncoupled from other people. So let's start with this metaphor. Think that I'm a speaker now, and I have things that I want to tell you, right? So I have brain patterns now that are related to what I'm going to say, and what I'm doing now by speaking, I'm sending this like sound wave to your brains, and now basically there is a coupling between your brain and my brains. My brain generates sound waves that go to your brains and change your brain patterns. And my task now is to take these brain patterns in my brain and put it in your brain. And that metaphor, although it's simplistic and not precise enough, will help us to go along. So in my lab, we really like to study communication in the real world, as I was saying, and we use really natural stimuli. So I will give an example of one stimuli that we used. There is an event in New York City. People go on stage telling real life stories, and you drink a beer and enjoy the stories. And I used to go to this storytelling when I was living in New York. And this is one storyteller, Jim O'Grady, and I will play you 20 seconds from the story, from the middle of the story.
So I'm banging out my story, and I know it's good. And then I start to make it better by adding an element of embellishment. Reporters call this making shit up. And they recommend against crossing that line. But I had just seen the line crossed between a high-powered dean and assault with a pastry. And I kind of liked it.
So we have people lying in the scanner, and we're looking at their brain patterns while they're listening to this real-life story, right? This is not an experiment. This is a real-life experiment. And the question, how can we do science with this real-life stimuli? So we developed a few methods that I'm going to talk you through, and let's start with the first one. We call it intersubject correlation. The simplest way to think about it, you have your responses while you listen to the story over time, and now you use this one brain of one listener as a model to predict the responses in another listener. If you take the same area, let's say this is the auditory cortex, you can see that this is responses over time, and now you can ask, is it similar to the responses in this other subject? There's another way to think about what we are doing. You can think that we're taking one brain as a model to predict another brain, and that will come handy in the next part of the talk. So you can see that during rest, before the story started, if you look on the 5 listeners over there, you can see that the responses are going all over. The brain is never at silent, but the responses are very different from each other. However, as we start the story, something happening.
So I'm banging out my story,
now you can see that the response is going up and down
start to make it
in a very similar way across all subjects. It's not a perfect correlation, but you can see that it's a very strong similarity across people as the story proceeds. So this is in the auditory cortex, and this is exactly what you expect from the auditory system, right? If now I'm going to do each click, your auditory cortex is going up, each silence it's going down. So it should be similar across all people. This is exactly what you expect. So in a way, there is something very trivial over here, that your brain becomes locked to the outside, but it's also something very deep, because your brain takes the shape of the outside. This is what brains are doing. So now we can go brain area by brain area and see, is it only in the auditory cortex that you see the similarity, or it's more extensive? And when we do this computation, and we go area by area, we get this map. This is not map of activation, okay? This is map of how similar the responses or the time course across people. The stronger the color, the more similar the responses. If you look in the gray, this is areas that are not similar across people. For example, look on the back of the brain, this is the visual cortex. Because it's an auditory story, you have no similarities in the visual cortex. If you will use movies, you will see similarities in the visual cortex. The motor cortex also is not similar because people are lying and cannot move. But if you look on the similarity, you see that immediately that it's not only the auditory cortex over here. There are many, many brain areas. This is the superior temporal sulcus. This is language areas. This is temporal parietal junction. This is high order parietal areas. This is frontal areas. This is Broca's areas. This is dorsolateral prefrontal cortex. Precuneus, MPFC, there are many, many brain areas while you listen to these stories that they have become similar. And now you can ask, why are they become similar? Is it still only the auditory aspect, the low level, or maybe we become also similar on the way we think, right? Maybe it's more interesting than only the auditory effect. So now we tested it. But before we say how we tested it, I want to say something. You can think about this alignment to the stimuli as neural entrainment, that you entrain by the outside. And to explain what is neural entrainment, I will first explain what is physical entrainment, and then we'll call back and talk about social entrainment, because this is what we care in this conference. So look on this 5 metronomes. And think about them like the brain. Before the story started, when you lie in the dark scanner and your brain are out of sync, right? And now I'm coming and I'm connecting these 5 metronomes together by placing them on these like 2 cylinders, right? And now the vibrations that go from the metronomes go to the wood and slightly shift this wood, and now all these metronomes are connected, and see what's happening. Now they become perfectly aligned. So this is exactly what's happening when I'm talking to you now. Your brains start to sync together. And now we should ask which aspect is driving this syncing. Let's say we are measuring the brain responses in this middle of the story, minute 3. Maybe the coupling happening because the sound that's happening right now, for example, this clap, right? You don't care what happened before or after, you have a brain response. Or maybe this responses now depends on what I was saying 200 milliseconds ago, let's say the phoneme in the words. Or maybe the responses over here depends on the word that I said before in a sentence. Or maybe the response depends on the sentences that came before. Or maybe your brain responses now depends on what I was saying at the beginning of a story, 3 minutes ago, okay? You can think about these responses that have no memory, living in the moment. And this type of responses is responses that accumulate the past and really influence but what's happening many, many minutes ago. So how do we know it? How can we tell what is the time scales of coupling? We simply change the past. For example, we can take this story and play it backward. And now you have all these like audio envelopes, right, that driving your coupling, but you have no meaning. I can define the boundary between words, and now I can scramble it, and you have a list of words.
Animal. Started fact, Sheila and Rakers comes and right, is it on Pie Man? Can I substantially my story? Said,
and you can do it for sentences.
Surfer from the ram, and then runs away. And they recommend against crossing that line. It says, Dear Jim, good story, nice details. Didn't she only know about him through me?
And of course you can do it for paragraphs. And now if you look on the brains, you can see that if you have only sounds coming, you become coupled to the outside. That's what your brains like to do, right? But you become coupled only in the auditory areas. If you start to add language by have a list of words, you become also coupled in early language areas. If you go to sentences, you can see now that you become coupled also in high-order language areas. And if you go to paragraphs, suddenly you can see that you become also coupled in high-order parietal and frontal areas. Okay? So now let's focus, and if you put it all together, you can see a very nice gradient of coupling. We can zoom in and you can see that early auditory areas become coupled early on to reverse speech. Basically, you can see that they become coupled to reverse speech, word scrambling, sentence scrambling, paragraph, and full story. If you go up the hierarchy forward, anteriorly or posteriorly, you can see that now you have no coupling to reverse speech. You need word or more to be coupled. If you over here, you see that you need sentences or more to be coupled. Word are not enough. And if you go even higher, you need paragraph or the entire full story to start to be coupled to other people. So there's some gradient going on. And now let's focus on these blue areas, because the blue areas is what I think what we care in this conference. We care about social interaction. We care about meaning. So these areas, in order to be coupled, I need to invest a lot of wording and time in order to make you understand me and start to be coupled to me. So how do we know that this is the case? We did the following experiment. First, we took a story in English and translated it into Russian. And now you have a very different words and linguistic system to convey the same meaning. And if I'm comparing the brain of English speaker listening to the English story, or the brain of the Russian listening to the Russian translation, because the sounds are very different, they are not coupled anymore in the auditory areas, but you can see that they start to be coupled in the outer areas, because these outer areas care about the meaning and they don't care about the words you use to convey them. We can go even deeper and say that shared meaning equals shared neural responses in these high order brain areas. So we did the following experiment. There is a classical either and similar phenomena that you all know as also scientists, right? You see this triangle and circle and see how they interact and try to come with a story of what's going on. So I'm not going to do this and ask you, but I can tell you from our experiment, some people think that this triangle is playing with the ball over here, and then the parent come and take him. Others think that the circle is a dog, and the triangle, the kid, play with the dog. Others think that the triangle is bullying the other kid over here. There are different interpretations coming on. And when you take this phenomena, and that was the beginning, and we started to say, let's do a movie of 7 minutes. Usually this is a very short snippet, and we like long stimuli. So now we created a movie of 7 minutes, that was its beginning, and that will be somewhere in the middle. You can see, so now many things happening to this triangle and square. And the movie goes on, and then we tell people, okay, tell us what was interpretation. And different people come with different interpretation. These two have very similar interpretation of the kid playing with the ball in the schoolyard. This one have a very different interpretation, right? That the circle was a pet, okay? And now we can ask, how similar is your interpretations, your social interpretations? And we can come to a similarity, how similar you are to another person that's listening to the story. And now we can take your brain responses and compute how similar is your brain responses to a different viewers in the same brain, in given brain areas. And now we can ask, where in the brain your similarity of brain responses predict your similarity in the interpretation, right? And immediately what we see, I'm missing the data slide, sorry, I'll look for it later. Basically, what we see, you see that these blue areas that care about the meaning, the TPJ, precuneus, middle prefrontal cortex, show correlation. So the more similar you are, the more similar your brain responses, the more similar your interpretation for this very abstract stimuli. So far we talked only about listeners, but I was saying that I want to study communication between me, the speaker, and you as listeners. So let's go to the listeners. To the speaker, basically we can record a speaker telling a story, and then we can transmit this story to other listeners and ask how similar is the brain responses of the speaker to the brain responses of the listeners. And you can see that over here we can use the same analysis we do, but because production and comprehension are very different processes, this model allows to ask whether my brain during production is similar to your brain while comprehending, right? But there is some time lag between us, because I need to think, then I need to transmit it to my articulatory system, and then I need to project it to you, and now you start processing. So there is some time lag between us. So we took my brain responses as a speaker, and we shifted back in time. And basically this model tests whether your responses now related to my responses a second ago. And I can also do the opposite and ask whether your responses now will predict my responses as a speaker a second from now. So that's like the prediction aspect of communication. And we took this model and we tested it, and we saw that basically all these many brain areas were similar or coupled between the speaker and the listener. So in a way you can think about it, that what's happening during communication, the brains of the speaker and the listeners become coupled, and what I'm trying to do by speaking, I'm trying to make your brains more similar to mine. And if we look at the understanding, basically, how do we know whether you understood me or not? It's very easy. I can ask you questions, right? I can give you an exam. Don't worry, I'm not going to give you an exam, but I can do it. But for the subject, we asked them questions about the story, and we saw that the level of comprehension varied across people. This guy got less from the story than this guy, right? And we saw that the stronger the understanding, the stronger the coupling with the speaker. So basically, if you get me right, I can tell you that your response is going to be more similar to mine. And if you are really confused, maybe you are over here, or maybe you are in the middle. So this is a conference about developmental, right? So now we can ask, how can we use this brain-to-brain coupling as a vehicle for learning, right? Because this coupling is really fundamental, and it can drive us a long way forward. So this is my son Jonathan when he was like 9 months. Now he's 10. And you can see how we invented a game with my wife only from the joy of being coupled. So I think it's not clear who is driving the coupling over here, whether it's my son driving it or my wife, but I can see that they're really having fun. And now you can think that if you have a coupling to another brain, now you can start to transmit more and more information, and you can teach them and give them supervised learning till the day of age 18 that they say, you know nothing, they leave the house and become decoupled, right? So I would say, okay, with Jonathan, it looked like an amazing, but I was like a young postdoc at the time. And I say, now I got like Aya, this is my third child, and I say, okay, I have the opportunity. We bought FNIRS device, and I say, okay, I'm going to do a developmental study in which I'm studying how I become coupled more and more to Aya over time, and it will be like really nice to see how it develops. The experiment failed because the equipment was new, we only bought it, and by the way, by the time we got good signals, she was already like 2. So basically we missed the window to do it. We say, okay. But we say, okay, there are other kids in the world, that's okay. So basically we started to do this experiment in which we see how the coupling between the experimenter and the baby develop over time as a function of the quality of the coupling. So over here, Liatma basically interacted with the babies. He sang songs and read books and an open game with them. And then the other control experiment, she interacted with another brain while the baby interacted with his mother. And you can see that there is a strong coupling between Liat and the baby over time. And you can see that this coupling is really getting stronger. We don't record from the entire brain. You can see where the electrode, we only record from the frontal cortex and the parietal cortex. You can see that it's stronger doing it together than they are apart. So basically, this is only the first study in a row, and now that we have this result, we started to go deeper, and in 2 years I can tell you more about this line of research. Now that basically we become coupled to each other, and as an adult we are very similar to each other, right? I can use these similarities to share meaning and also to share memories with your brain. So to show you how we do it, we did the following experiment. Basically, we took a movie and projected it in the scanner for the first time for people that watched the movie. How many of you saw this pilot of Sherlock from the BBC? Okay. So, not too many, actually. Okay, I would say like 20%. So for some of you, I'm going to trigger a memory. From some of you, I'm going to inject a new memory. Okay?
What about these suicides then, Sherlock? Thought that'd be right up your street. 3 exactly the same.
4.
There's been a fourth. There's something different this time.
A fourth?
Where?
Brixton, Lauriston Gardens.
What's new about this one? You wouldn't have come to get me if there wasn't something different.
You know how they never leave notes?
Yeah.
This one did. Will you come?
Who's on forensics?
It's Anderson.
Anderson won't work with me.
Well, he won't be your assistant.
I need an assistant.
Will you come?
Not in a police car, I'll be right behind.
Thank you.
Brilliant! Yes! 4 serial suicides and now a note. It's Christmas. Mrs. Hudson, I'll be late. Might need some food.
I'm your landlady, dear, not your housekeeper.
Something cold will do. John, have a cup of tea. Make yourself at home. Don't wait up.
Okay, so people are watching this movie and we scan their brains. And now we give them the opposite condition. What is the opposite condition? Now instead of watching a very strong audiovisual coming to your brains, now you lie in the scanner, in dark, no other people, you are by yourself, there is no stimuli. We give you a microphone and tell you, can you tell the story to other people, okay? And I'm going to play you a recording in the scanner of someone recalling the beginning of the scene, see if you can understand.
And ask if everything looks okay. And she picks up the newspaper and she's asking Sherlock about the murders that have happened. And Sherlock briefly looks outside and he sees that there are cop cars. And he says that there's been a 4th murder and something must have been different. So that's why they're there. And
okay, so the recall was very detailed. People were really good in this task. And now, when we're scanning the people while they're speaking and compare it to the moment they watch the movie, we can ask which areas in the brain, while speaking, while you use language, reactivate your patterns of brain responses while you really experience the event. Okay? So that's called memory reinstatement. And now we can take this recording and we can play it for a group of listeners that never watched the movie. And now we can ask whether this, like when you reinstate your memories over here, can we find them also in the listeners that never watched the movie? And this is the pattern of communication. And now we can really even close the circle and ask how similar is the brain of people that listening to you while you describe the movie to the responses of yourself while you were watching the movie, okay? So we can close the circuit. This is one subject that described the movie. This is the behavior. You can see it took 50 minutes to watch the movie. We segmented the movie to 50 events. And it took this viewers 22 minutes to tell it. So there is a compression. There is moment, this is the event that you remember, okay? There is also events, usually you remember it in sequence. Sometimes you remember it out of sequence, and sometimes you forget events. But mostly you have a very detailed memory of it. This is the 17th subject. You can see we have one subject over here that it took her 45 minutes to describe 50 minutes movie. I'm not sure she was the best storyteller actually, because she went into too many details. Probably you have this experience of people that telling everything. But even the more efficient speakers that took them 15 minutes to tell were very detailed and didn't miss scene. Okay, so we have a very good behavior. And now we can do this analysis, but instead of doing it over time, we're going to do similarities of patterns over space. Let's say this is scene 1. We take the brain patterns over here in a given brain area, and while you watch, and we correlate it with the brain patterns while you listen, or while you speak, right? And we can do it for each scene. And then our statistics is compare across scenes. For example, scene 22 to scene 2. So basically, you want your brain patterns while you remember this particular part of the movie to be very similar to your brain patterns while you watch this particular part of the movies, and different than other part of the movies, okay? And basically, when we do this analysis, we first compare the brain responses while viewing to while remembering and speaking. And we can see that there is many brain areas. Again, this high-order network that you start to be familiar with become very coupled when you're viewing the movie and when you use words to describe it, okay? And now we can go to the communication part and ask whether your brain responses while speaking is similar to the brain responses while someone else is listening to you, while you never watched the movie. And you can see that the responses, again, are very similar. And then we can finish this cycle, right, by looking how similar is your brain responses while you're listening to the brain responses of people while they're watching. Now, this is an interesting comparison because over here I need to think about the detective. I'm going to do some spoiler of the movie, okay? That will be fine. Basically, this is Sherlock. This is the taxi driver. And the taxi driver is also the murderer Sherlock is looking for, right? So now Sherlock is going in London to the taxi driven by the murderer. So when I was saying it to you, I had to go back to my memory of the movie and retrieve it. And I was saying London, detective, murderer, taxi, and you had to imagine it because you never saw the movie, right? So for me, it was memory retrieval. For you, it was imagination. And now we can ask whether memory retrieval and imagination are similar, and you can see that this is exactly the case. So basically, what's happening over here is that I have an experience, and then I can use words to evoke it in my mind and place my memories in your brain now, and you also start to imagine it. So there is a very strong connection between imagination and memory. And maybe this is the essence of memory, because the past is gone. Why do I care about the past? I only care about the past because it helped me to imagine the future. But it's also that you can see there is something over here that is really important. In order for you to understand me, we need to have a common ground, right? If I will use other words for taxi instead of cab, for example, acne carrot, this is only British people will know, will not be aligned, right? So we need common ground to understand it. And this common ground leads us to the other part. How do we become uncoupled from other people? Because we already seen in this experiment that the more similar you are to other people, the more similar brain patterns are, right? So we know that there is a deep connection between similarities and the way we think. But there is something more complicated in the way we need to understand this picture, right? Because it's very easy to me to be coupled to your auditory cortex. I only need to say blah, 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 and we are coupled. I don't need to have an effort, right? But in order to be coupled in these other areas, we need to agree on the common ground, right? So in a way, there is a filter between me and a speaker and you, and this filter is what you believe in, what you know about the world, and this is the way that you take my meaning and give it interpretation. So in order for us to be coupled in these other areas, we need to have very similar filters that help us to be coupled. So how did we test it in an experiment? This is an experiment done by Yara, and I just saw Yara, so Yara is over here. So basically, in this experiment, we took a story by J.D. Salinger, and it's a very simple story. Husband lost track of his wife in a party. He goes back home after the party to his apartment alone, very stressed. It's midnight. Where is my wife? He's taking the phone, calling his best friend. Next to the best friend, there is a mysterious woman, naked. We don't know who she is. Salinger is smart, never tell us who she is. As a good scientist, we ruined the ambiguity. And basically, we told half of the people we were telling him the naked woman is the wife, having an affair with the best friend. So now we gave the subject a filter to understand this story. For the other group, we were saying the opposite. We say the wife is loyal, the husband is jealous and weird, okay? And this mysterious woman is the girlfriend of the best friend. Everything is fine. So now we gave them a very different filter. And now you can choose which filter you want, and I gave you 20 seconds from the story.
Joni was leaving, Did you happen to notice if she left with the Ellenbogans by any chance? The gray-haired man looked left again, but high this time, away from the girl, who was now watching him rather like a young, blue-eyed Irish policeman. No, I didn't, Arthur. Didn't she leave with you? No, Christ. You didn't see her leave at all, then? Well, no. As a matter of fact, I didn't, Arthur.
Okay, so I want you to look for a second on the story. Basically, we all understand what the husband is asking, did you see my wife? We all understand that the friend say, I have no clue where's your wife. Can I come over? Basically, then you're asking, can I come over? And say, no, I'm tired. And we all understand the answer and the situation, but some of us think, oh, the friend is lying, he's not tired, he doesn't want to be caught. The others say, of course he's tired, this is an annoying guy, right? So 5 minutes will be fine. So basically, when we look when we gave people general comprehension questions, they all say, understood it in a very similar way. But when we ask specific questions, for example, is he lying or not, we can get the opposite responses. So now you can see that these filters doesn't change everything. Most of it is the same, but it changes this like small interpretation that really make a difference. So now what we did, we train the classifiers. We told the classifier this is the responses in one brain areas for group in context 1. This is the responses in group number 2. Now you get a new subject. Try to guess, is it belong to this group or this group? Is it more similar to this group or this group? Chance level is 50%, right? When we do these classifiers, we can classify around 85 to 90%. What was your interpretation? But only in these other areas that care about meaning, right? So now it's telling you that even one sentence was enough to make you more similar to people that have similar information. And now I want to ask you a question. Basically, so that's the finding. I want to ask you this question. Let's take an imagined world. I cannot imagine it will happen in real life, that the president of the US have an affair with a Playboy actor, right? And now you should ask, is it true or fake news? How do you know? You don't know, ever? So what do? You are all scientists over here. How will you know?
We know the past, we know the ideas, we know what happened before.
How do you know?
I read.
Okay, so basically, you need to do investigation, right? People tell you stuff all the time. How do you know? You investigate. There is reality. Either he slept with the Playboy or he didn't. There is reality. But you have your own filters. You never know the reality. You only know your filters. And now you know. You see recording from his lawyer coming out. You see investigation. You see the money trail. You do the investigation and then you decide. But these filters are very important, right? So basically, there is one thing is what you think and the other what reality. And it's really important to know the difference and to understand it. So now you see that understanding from where these filters coming is very important for us, right? It's a very important question. And from where you get your filters, you get it from the brains you are coupled with, right? Now we go back to the beginning of the talk. Tell me who is your friends, I will tell you who you are, right? If you have different friends, you have different way. But it's also coming from the media. Someone is really manipulating the way we are thinking, right? Influencing the way we are thinking, right? So if we leave, for example, other people and we look only on the media, something really interesting happening now in the world, because basically, I don't know, do you remember the shooting in Las Vegas? There was a feed that's saying that the guy that shot was a Muslim. There was a feed like that. Do you remember the shooting in Florida in the school? There are many shootings in the US now. Basically, there was a feed that was saying that these testimonies were fake and they were like liberal actors. The shooting never happened. So now we have people that have very strange filters And this is the interpretation they get for their life. And this filter is running on media social and in Google and in Fox News and really changed the way we are thinking. So now we see that it's really important to understand how this filter is coming. So we did a study that I'm not going to talk now because it's ongoing and I ran out of time. He's relieved, I feel, and I'm going to skip this study. Basically, we downloaded all the transcript of MSNBC, which is like a liberal media, and Fox News, which is more conservative media. And now we're running word-to-vec modeling, and we try to understand how different is the semantic, the way they use words. Going back to Wittgenstein, how different is the way they use words. And now we come with a very different semantic spaces for these two media, and we're going to see how people run different sources of semantic models in their brains because they are exposed to different input. How the statistics of the outside shape who you are. Okay? So let me wrap up. Maybe my computer died and that I can also. Okay, so I'll simply wrap up and say, we're living in, Okay, I'm wrapping up. We're living in a world in which we are shaped by other people. If we want to understand one brain, we need to understand how it's connected to other brains. That's our task. It's very easy to study one brain in isolation, but we're missing the forces that shape us, right? So the task now is to go to this like natural, complicated, messy human existence and start to do science in this messiness in order to understand who we are and where we are going. Thanks.
Replicating what the Buddha said 2,000 years ago. But seriously, if you have people and you have people that are able after a very long time to get better in not being biased by filters, how would you predict when they're interacting with people, how would you predict the brain response to be more or less?
I don't think that you cannot be biased by filters. I think we all, if you read Haaretz, you have a filter. If you read Israel Hayom, you have a filter. We all have a filter. We should be aware of it. I was going back to Hannah Arendt writing recently because it's all feels very related. And basically, her solution, and I don't have any support scientifically to say about it, but her solution was you have your filters, you have your biases, but always be also a scientist and be critical and think for yourself. And this is why I was like waiting, lingering on what is the truth. You have your filter, you have your biases, but how do you know which interpretation is true? And if you keep thinking and do the investigation and read many channels, don't listen to one media and be critical of what you're reading, maybe you can downplay these biases and start to think by your own. And otherwise, bad things are going to happen, I think. Okay, thanks.